Now, this question is based on the impulse momentum theorem. Okay, I'll just go through that theorem first and then apply it in this question. So, what do you mean by this impulse momentum theorem? As per the theory, the change in momentum, so P stands for momentum, will be equal to impulse, right? Will be equal to impulse. And impulse, by definition, is the force times the time for which the force is acting on the object. So, either if you are given with change in momentum, you can substitute that and equate to impulse, or you can substitute force times and then equate it to impulse, or sometimes from the impulse you will be asked to calculate force and so on. So but then the basic relationship you need to remember is this impulse momentum theorem, how they are related. Change in momentum equals impulse. So then by finding that, you can go ahead and find the force as well. All right, now let's look into this question. It says a 2200 kilogram vehicle traveling at these many kilometer per hour. Now they have also given you in meters per seconds. I would advise you to be familiar with this conversion. Kilometer per hour, how do you convert? You multiply it by 1000 and then divide it by 3600. So you can check that calculation whether you're getting 26 from here. 94 times 1000 upon 3600, you should get 26 meters per second. All right, can be stopped by 21 seconds by gently applying the brakes. It can be stopped in 3.8 seconds. So notice the difference. This is 21 seconds, the stopping time, or it could also be stopped by 3.8 seconds. Approximately like 5 times larger is the time here if the driver slams the brakes, or in 0.22 seconds if it hits the ball, if it hits a concrete wall. That's like if it meets with an accident, it might come to an abrupt stop, so less than a second this time, or a sudden application of the brake would take approximately 3.8 seconds, or a very gentle slow stop could take 21 seconds. So those are all the information given to you. Now, what's the question? What is the impulse exerted on the vehicle? And then that's the first part of the question. Second part, what average force is exerted on the vehicle in each of these stops? Okay. What you need to understand is that the change in momentum in every situation, the initial momentum does not change. Why? Because that depends on what's the formula for momentum? P equals m times v, right? The start speed is not changing. The speed of the object is 26 meters per second. So you get the mass is 2200. So times 21. So this does not change in your answer or in each of these calculations, right? Then it comes to a stop. So this is your P initial momentum. Final momentum will be 0. Why? Because mass times 0. So your final momentum is 0. So this change in momentum is equal to impulse, right? So 2200 times 21 equals, you get 46,200. So the initial momentum, so the change in momentum, that is delta P, will be equal to P final minus P initial, right? So that's equal to 0 minus 46,200. Now this is the change in momentum when the object comes to a complete stop. Now this could happen. Complete stop can happen in 21 seconds, 3.8 seconds, and 0.22 seconds. Now, for the first part of the question, what is the impulse exerted on the vehicle? It will be this same answer because change in momentum equals impulse itself. So, the first part is answered already. What did we find? The initial, final momentum, the difference in them gives you impulse. So, part A is over. Now, for part B, what average force is exerted on the vehicle in each of these stops? So, that is when you need to calculate for 21 seconds, for 3.8 seconds, and 0.22 seconds. So, if I take this as first situation, this as the second, this as the third, okay, for the force for first one times the time will be equal to. So, impulse formula is what I gave you earlier. Force times time equals impulse. So in first condition or first situation, it takes 21 seconds and that will be equal to negative 46,200. Right? So the same calculation you will do it for force 2. That will be again equal to the impulse. See, notice the impulse does not change in this particular situation, but the time changes, therefore the force that is acting on the vehicle also will change. So here in this case it is 3.2, which is equal to I. Then for force 3, again the same impulse. So F3 times 0.22 will be equal to again negative 46,200. So individually you will calculate F1, F2, F3. How do you calculate this from here? Negative 46,200 upon 21. Correct? Because since it's division, so multiplication, it becomes division. So you'll get 3 different forces. This question actually makes you understand how this impulse is related to the force and the time that is acting on an object. If the force is larger, the time for which it comes to a stop is smaller. So the impact is greater. So you all will definitely understand if the car comes to an abrupt stop in 0.22 seconds when it hits a concrete wall, the damage caused to the car is much, much larger. The reason being the force that is acting on it will be greater as well. Okay, the final answer you should be getting, yeah, that's a calculation for the 3 different forces. So if you notice here, see for the 21 seconds you have, if you put it in the normal numerical number, negative 2,700, right, Newton you will get, and the second one will be 15,123. So you get, here you have 2, 6, 2, 3, 4. See, notice there, when it is gentle braking, the time is more and you get 2,700 Newton. The negative sign actually shows that the force is in the opposite direction to the object's movement. All right, because it's coming to a stop. So the force is acting on the car and it is 2,700. If it takes 3.8 seconds, it is 15,000 Newton, much, much larger. And if it is 0.2 seconds,